Hello, my name is Bryan Jose, and this is my final video project for Engineering Materials 201. The topic is Lego manufacturing. Legos are one of the most well-known building toys in the world, and they have a reputation for high quality, which has lasted for a long time. Part of the reason for this high quality is the choice of material which the Legos are made of. So today we will be going over what that material is and why it was chosen. So the first obvious requirement of Legos is they have to be strong enough to not shatter or break with constant use. If they're dropped on the floor, you don't want the individual pieces to break, the set breaks instead. But the individual Legos don't break. So obviously the material you use has to be rather strong. It has to be hard enough to keep from getting scratched up from general use. It has to be lightweight enough to be easy to play with and use and does not get tiring to use after a long time. They have to be flexible enough to do the tiny amount of stretching that they use to hold on to each other, but also rigid enough to keep from just slipping apart. They have to be easy to mold into a variety of shapes, as Lego has a wide variety of types of pieces. And they need to hold color and the shape for a long period of time. Immediately, we can discount metals, as they are too rigid, too heavy, and their coloring is inconsistent. The only way to give them the bright colors that Legos use would be painting, and that would wear off over time. Ceramics, obviously, are much too brittle and also heavy. They would be much more likely to shatter than Legos should be. Polymers are our clear winner here. They fit all the needs and are cheap enough to be very viable, whereas composites obviously would not be homogeneous enough to be molded the same way. So Lego chose ABS plastic, and for good reason. It's used for most Lego elements with the exception of things like tires and similar pieces. It's an amorphous polymer with no melting point, and it has a high enough glass transition temperature that you're not going to have your Legos start to soften in normal conditions, unless you get quite high temperatures. Most people's houses aren't at the levels where their Legos would start to soften. Its surface is relatively shiny and tough, so you don't have to worry too much about it getting scratched, and it has a high enough hardness and rigidity that it won't just break. It's also known to be easy to process. In fact, it's used in many 3D printing applications because it's easy enough to process. And this, of course, lends itself to being molded into the variety of shapes that Legos come in. The process begins when ABS pellets are heated, and the ABS pellets start at whatever color the end piece should be, but they're heated to around 232 degrees Celsius until they reach a dough or toothpaste-like consistency. Then they are piped to the molding machines, and air injected into the molds, an example of which is shown in the picture, at extremely high pressures, from anywhere from 25 to 150 metric tons. They are then cooled over a period of about 15 seconds, which allows fast cooling allows the plastic to stay hard as opposed to soften up as if it were given more time. The end result of all this is Lego blocks, one of the most well-engineered and just precise toys in existence. These blocks come in a variety of shapes and forms, but with them we can make almost anything we want. They are so high quality that finding an actual broken or malformed Lego piece is extremely rare. Even finding that a set doesn't have the right number of pieces is amazingly uncommon. And these reasons are why the Lego company has been known as one of the more high quality toy makers that exists. And the way things seems like they will continue to keep that reputation for quite a long time. This has been my report. Thank you.